why consider this? Why are people considering this? Well, first, climate crisis. We're facing, I believe, I suspect several of you believe, we are facing a climate crisis. Every year, the evidence grows stronger that the Earth is warming and that this warming is causing climate changes. Global data just for last year, for 2010, shows that 2010 tied 2005 as the hottest year since record keeping began in 1880. It was also the wettest year. Arctic ice in December 2010 was at its lowest level for December since satellite pictures started being taken. I guess I said this, I'm getting mixed up. It was the wettest year in the historical record, which is entirely consistent with predictions that a warming Earth will increase the intensity of the hydrological cycle. There were especially powerful snowstorms, as you know, in the US and in Europe. Pakistan endured an unprecedented and really horrifying floods and rain. There was also flooding in Australia and California. None of that's uniform. On the other hand, in the Amazon, they had their driest summer or driest year in decades. On the oceans, the die-off of the coral reefs continued and intensified, something that most scientists attribute to warming and acidification in the ocean. So we've got tremendous evidence that this problem is not, is intensifying and is reaching a crisis proportion. Past scientific predictions about how fast these things would happen have proven to be conservative, not over predictions, but under predictions. So change is happening faster than we thought, and it also appears that some of the consequences might be more severe than we thought. And those consequences are very frightening indeed. I'm sure most of you have heard of them, but I'll just mention a couple of the concerns that are primary when we think about this. First of all, projected sea level rise, not in the short term, but over the long term, we hope, will displace millions of people from their homes or cost billions of dollars to build the seawalls and the other things to protect those homes. The effect will be the most severe in some of the poorest countries of the world, like Bangladesh, and in small island nations, which might disappear altogether. Changes in precipitation and temperature patterns are going to affect agriculture and food production worldwide, with significant adverse impacts on food security and rural economies in many parts of the world. And all these changes are also likely to create, in the long run, large population movements as environmental refugees move from one place to another. And in parts of the world with weak governments and not very much money, we can expect that the political stress, including wars and mass killings, will be a reality as that happens. We are, in addition, closing in on certain tipping points, points at which climate change could intensify because of feedback effects that it induces in the planet, and after which the job of getting back to where we were will be that much more difficult. So we face, in the minds of many, me included, a crisis. People know what must be done. We have to cut greenhouse gases soon and rapidly, and people know how to do it. But sadly, we've failed to do it. And that's the second reason climate engineering is on the horizon. Our diplomats, our diplomatic efforts, the international community, but also our own domestic political system, has been unable or unwilling to address this problem in a way that looks to be both serious and effective over the long term. So those two things combined, a looming crisis situation and a continuing diplomatic failure to come to grips with that situation, are primarily responsible for increasing talk about geoengineering as a solution. In addition, you've got the fact that it's potentially less costly than reducing greenhouse gas emissions. And finally, the argument that even if it's not a sensible long-term solution, it might be a viable solution for quick deployment as we work on a long-term solution. But for that to work, of course, we have to do the research and planning now. Now, all of you are here, so you're probably not surprised. Well, I'm sorry, no, I'm getting ahead of myself. So what's the other side of the coin? So that's the coin, the offer that people make for geoengineering as a solution. What's the other side of the coin? Well, first, there's the moral hazard issue. If we start talking about climate engineering and people think, oh, geez, for a fraction of the cost, we can shoot sulfur into the atmosphere and cool the Earth that way, then you're going to weaken the incentive, maybe for the better, maybe not. I won't judge. You're going to weaken the incentive to do the harder thing, which is reduce and get control of greenhouse gases. Second, geoengineering, all the geoengineering proposals pose certain risks, some of them unpredictable, some of them predictable. I'll take the two that I was talking about, iron fertilization and sulfate aerosols. Iron fertilization will increase phytoplankton growth. That's the hope. That's how it's supposed to work. Assuming it does work, that sounds pretty good. But there is a risk of some significant alteration of the marine ecosystem, which might or might not be positive. Phytoplankton are the foundation of the food chain in the marine environment, so maybe more phytoplankton means a healthier marine environment. Maybe it doesn't. Krill, which are little tiny shrimp-like critters that are very important to the marine environment, especially in the Southern Ocean, feed on phytoplankton, so increasing the amount might help them. On the other hand, krill lay their eggs or have their offspring born just below the surface of the ocean, and if the phytoplankton decay and use up all the oxygen, that could upset the breeding of the krill and wipe out their populations. We don't know which way it will go. So it could be positive, it could be negative. The point is that there's a risk of significant impact on the ecosystem that we aren't able wholly to predict. Take the problem of, or the possibility of injecting sulfate aerosols into the atmosphere. We know from observing volcanoes and volcanic activity that doing that will have a cooling effect. And if we can keep it up over a long enough period of time, you'd have to occasionally re-inject every couple of years. You could counteract, in theory, the climate change. But we also know that this will have a weather impact. It might disrupt traditional rain patterns to some countries, causing the monsoon to disappear and the crops to wipe out. It could increase the rain in other areas, causing flooding and other problems. And it may do things that we can't at this point predict because we don't have full knowledge and understanding of how the sulfate aerosols interact in the atmosphere. So there are problems and risks, and those in the minds of some are reason enough by themselves not to pursue a climate engineering solution. And finally, we have to recognize, even if we do pursue it, that in many cases it would be an incomplete solution, especially solar radiation management, which does nothing about acidification in the oceans and moreover has to be maintained over a long period of time, or you run the risk of dramatic and sudden warming if you stop doing it. So these are incomplete solutions. So, are they serious, or meaning the people who talk about this serious? Well, you bet, absolutely, and more so every day. Here's a list of just a few of the groups in the last 3 years that have come out in support of at least research and perhaps real-world experiments with various kinds of climate engineering. The Royal Society in the United Kingdom in 2009 endorsed it. The National Academy of Sciences in the US in 2010 endorsed it. A conference at Exlporer on climate engineering in 2010, which had representatives of academics, government, and NGOs, came out in support. A U.S. House committee and a U.S. parliamentary committee have been holding hearings on the issue to decide whether they should come out in support. Leading climate scientists, including several Nobel Prize winners, have advocated in favor of climate engineering. Entrepreneurs are coming out of the woodwork. There are several companies that have patents on various ocean fertilization techniques. They, of course, would love to see us pursue this. Bill Gates is rumored, but in the legitimate press, to be privately supporting climate engineering activity and investing in high-tech climate engineering companies. And the climate change skeptics, this is perhaps the greatest irony of all. The climate change skeptics, many of whom say we don't understand the atmosphere enough to know whether climate change is really happening, are now saying we don't have to do anything about climate change because if it is really happening, we'll be able to engineer the atmosphere to counteract it. I think that you'll see this in much of the literature. So we've got really, how do I put it? Well, I'll come back to that. We've got, but we do have a lot of interest in this and a lot of forward momentum to do the fundamental research and maybe even the actual experiments necessary to see whether any of these techniques will work.